Here's a list of properties of the dot product, but probably the best property of the dot product is a formula that allows us to calculate the angle between the two vectors. This formula is cosine theta equals the dot product of the vectors divided by the magnitude of each vector multiplied together. So box that in. That's a big formula that tells you the angle between two vectors, basically. So example 7 says find the angle between those two vectors. So we look at the formula, cosine theta equals the dot product divided by the magnitudes, the product of the magnitudes. And so look at your vectors. Here's u and here's v. We're going to dot product, so multiply those and multiply those. Dot product is going to be 3 times 2 is 6, plus 4 times 1 is 4. We can tell that dot product is going to be 10. That's the easy part. And something to note is that when we get a positive value right there, I already know that the angle between the two vectors is going to be acute. Okay, if that number is positive, the angle is acute. If that number is 0, it's a right angle. And if that number was negative, it'd be an obtuse angle between the two vectors. So right now I know it's acute, but I want to know specifically what it is. So then look at the bottom of this formula. We need to find the magnitudes of the vectors. Remember, the magnitude of a vector is square root of a squared plus b squared. It's just like finding the hypotenuse of a right triangle. But here's a and b for your vector. So for vector u, the magnitude is going to be the square root of 3 squared plus 4 squared. And for magnitude v, we'll do the same thing. It's going to be the square root of 2 squared plus 1 squared. So I have the square root of 9 plus 16 is 25, square root of 25. Square root of 25 is 5. And I have the square root of 4 plus 1, that's the square root of 5. So magnitude of u is 5, and the magnitude of v is the square root of 5. And so if we clean up this formula, I have cosine theta equals 10 over 5 times the square root of 5. Now you might be wondering or thinking that we need to rationalize that, and it doesn't really matter. I suppose it doesn't hurt anything, so let's go ahead and rationalize. It doesn't really matter, though, to rationalize, because in order to find theta, and that's what we want, we're going to have to do an inverse cosine. And the calculator doesn't really care what you plug into the calculator. So theta is going to equal inverse cosine of whatever that was that we plugged in. So whether you rationalize or not, it doesn't really matter. Let's do an inverse cosine. What we have is 2 times the square root of 5 divided by 5. Okay? So 26.6, theta is about 26.6 degrees. I'm talking about the angle in between the two vectors. Now remember, we knew that it was going to be acute as soon as we got that dot product value of 10, but specifically, that acute angle is 26.6 about. So this chart kind of sums it up, and it says if that dot product is positive, like the number we just got a positive 10. So if it's positive, we're talking about an acute angle between the vectors. And what I mean by that is, here's vector u, and here's vector v. This angle right here in between them is an acute angle. If the dot product is 0, we call that orthogonal. And that's talking about a right angle, or a 90-degree angle in between the two vectors. So that's like if this is vector u, and this is vector v, and that's a right angle, those two vectors would be orthogonal. And then a negative value, if you would get a negative value for the dot product, that's going to be an obtuse angle. So I've already talked about this, but if the dot product is 0, then that's going to end up making cosine theta equals 0. And you can solve that equation to find a 90-degree angle. we're talking about perpendicular vectors. And that's where this word orthogonal comes in. Orthogonal. Talking about perpendicular vectors.